Let's talk about indeterminate forms, specifically when you get 0 over 0. So let's say it's something like the limit as x approaches 3 of x squared minus 9 over x minus 3. By the direct substitution method, you're supposed to go ahead by substituting in x equals 3 into the limit. And when you do so, you'll get 9 minus 9, which is 0 over 0. And this is a situation where you're going to go ahead and evaluate by factoring. So the top is a difference of squares, x minus 3, x plus 3. The bottom is x just x minus 3. Once you reduce, you plug back in. So you plug in a 3 for x, and you get an answer of 6. And evaluating these indeterminate forms, specifically 0 over 0 indeterminate form, you're going to see that it's either going to be by factoring or by common denominator. Let's have limit as x approaches, let's say 7 of 1 over x minus 1 over 7 divided by x minus 7. Again, if you plug in, you'll get 1/7 minus 1/7. This is 0 over 0. So we got to find a common denominator here. So we have, let's see, for this common denominator, in the numerator, it's just 7x. You multiply by 7 over 7, x over x. And so now the new numerator, still write limit, because you haven't taken the limit yet, 7 minus x all over 7x, all divided by x minus 7. Well, divided by is equivalent to multiplying by the reciprocal. Now, these two do reduce, but you have to factor out a -1 in its place, leaving you with -1 over. Now I'm taking the limit, so I'm no longer going to write limit anymore, but I'm going to plug in a 7 for x. 7 times 7 will give you -1 over 49. And then another way you might evaluate an indeterminate form, 0 over 0, is if you get a square root. So let's say the limit as x approaches, let's say 2, of, let's go for the square root of x plus, we'll do 7 minus 3 over x minus 2. And yes, I'm doing these all in my head because, that's what I do. Plug in a 2, square root of 9 is 3 minus 3 is 0 over 0. So in this particular case, you're going to use a conjugate. A conjugate just differs in the middle sign, this middle sign right here. So I'm going to multiply by the square root of x plus 7 plus 3, the square root of x plus 7 plus 3. And when doing so, that's equivalent to doing a difference of squares, like x minus y times x plus y will give you x squared minus y squared, because it's just two pieces of a difference of squares. In this particular case, though, let me get that out of the way so it doesn't confuse you. Hopefully it didn't. Brought to light. You're going to have the limit as x approaches 2 of the first term squared, x plus 7, minus the second term squared, 3 squared is 9. Now you can conjugate the numerator, or it could all be on the denominator. This could be literally a flip problem, and you do the same process. If you notice on top, x plus 7 minus 9 is just x minus 2, which cancels with x minus 2, leaving you with 1 over. Now plug in a 2 for x. Square root of 9 is 3 plus 3, giving you an answer of 1 over 6. And that's how you encounter dealing with square roots, common denominators, and factoring when you have an indeterminate form, specifically 0 over 0.